All right, so 8.5, we get into other quadrilaterals. We're going to start talking about what a trapezoid and a kite are. So a trapezoid is a quadrilateral with exactly one pair of parallel lines. So it looks something like this. I'm going to zoom in. A picture would be parallel, parallel, and the other two sides are not parallel. So that would be a trapezoid. The base of the trapezoid are the parallel sides. So right here would be one of the bases, and the bottom is the other base. The base angles of the trapezoid has two pairs of base angles. Each pair shares a base as their side. So for example, up here, those blue ones are base angles, and the green ones are base angles. And by the way, I'm not trying to say that they're congruent. I'm just saying that the blue ones are one pair of base angles, the green ones are another pair. Okay, the legs are the two non-parallel sides. So like up here in the same drawing, we have a leg and another leg. An isosceles trapezoid is a trapezoid in which the legs are congruent. So the legs are equal to each other. So that would look something like this. We have our parallel sides, and each leg would be the same. So like, let's say they're both 10. That's an isosceles trapezoid. And the mid-segment is the segment that connects the midpoints of the legs. Okay, so we're going to add a picture of these as well in a second. The kite is a quadrilateral where there are two pairs of congruent sides, and those are the consecutive sides. The opposite sides are not congruent in a kite. And we'll talk more about that on the back side, but it will look something like this. Okay, so the adjacent sides are congruent, but the opposite sides are not. All right, so right here we have a trapezoid, parallel sides. Okay, we have the legs, and then we have, this is leg, and then we have base 1 and base 2. Okay, and over here we're just going to draw an isosceles trapezoid. Isosceles trapezoid. So that would be when the two legs are congruent. Okay, so that's the difference between a regular trapezoid and an isosceles trapezoid. Okay, example 1, I'm just going to briefly talk about, if we have a picture on a grid, how can we show that this is a trapezoid? We have to prove that one pair of opposite sides are parallel. So clearly, these sides in blue are not parallel. They're clearly going to cross. So we got to look at the red sides. Okay, the slope of DE is up 1, to the right 1, 2, 3. So the slope is 1/3. We also have to look at the slope of CF, this red side. So this is up 1, 2, to the right 1, 2, 3, 4, 5, 6. So it's 2/6. And 2/6 is 1/3. So what we have here is we have a pair of two sides, so the opposite sides, and they are parallel because they have the same slope. So is this a trapezoid? Yes, because the opposite sides are parallel. All right, theorem 8.14 says that if a trapezoid is isosceles, I want to make sure I spell this right, it's S-C-E-L-E-S, then each pair of base angles is congruent. So basically, it's a trapezoid, and each leg is congruent. That means that the base angles on the bottom are going to be equal, and the base angles on the top have to be equal. So the base angles are congruent if it's an isosceles trapezoid. Theorem 8.5 or 8.15 says if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So if you see the base angles are congruent, then you know it must be isosceles. So basically one of them implies the other. And theorem 8.16 is a trapezoid is isosceles if and only if its diagonals are congruent. So that means this line and this line are congruent. So if we label them, we would say AC has to be equal to BD in order for it to be isosceles. So isosceles trapezoid is the one special trapezoid where base angles are congruent, diagonals are congruent, and that's about it. So in example 2, it says a shelf fitting into a cupboard in the corner of a kitchen is an isosceles trapezoid. So this is the shelf that's going to go in the corner of your kitchen. Find the measure of angle N and measure of angle L and the measure of angle M. So we know that it's isosceles. So if it's an isosceles trapezoid because the legs are the same, that means the base angles have to be congruent. So that means the measure of angle N is equal to 50 degrees. Okay, and the reason is the base angles must be congruent. Okay, next we have to find out one of the other angles. If I zoom in, we have parallel lines, and these angles here, angle L and angle K, are consecutive angles or same side interior angles. So those are supplementary. That means angle L plus 50 degrees is equal to 180. And if we solve this, angle L is equal to 130 degrees. So if angle L is 130, we know that angle M is also 130 degrees because L and M have to be congruent because they are base angles and it's an isosceles trapezoid. So the blue angles are equal and the red angles are equal. Checkpoint, find the measure of angle C, angle A, and angle D. Well, it's an isosceles trapezoid, so angle C must be 135. They have to be congruent. We know that the measure of angle A and angle B have to add up to 180, so angle A plus 135 is equal to 180. So we subtract 135 to get angle A is equal to 45 degrees. And if angle A is 45, that means angle D is also 45 degrees. That's how we work with an isosceles trapezoid. Mid-segment theorem. Right. The mid-segment of a trapezoid is parallel to each base, and its length is equal to 1/2 the sum of the lengths of the bases. Right, so the mid-segment theorem, if we're going to write this, let's label it first. So we have A, B, C, D. Right, and these lines are parallel. Now we're going to connect the midpoints, so it would look like this. And the midpoints are going to be M and N. So right now, MN is the mid-segment. So the theorem is going to be, or the equation is going to be MN equals 1/2 of AB plus DC. That's our mid-segment theorem. So down here, Example 3, we'll work on it. It says in the diagram, MN is the mid-segment of the trapezoid PQRS. Find MN. So MN, in this case, is equal to 1/2 of 16 plus 9. So MN is equal to 1/2 of 25. So MN equals 12.5 inches. Okay, and it's as easy as that. So in the checkpoint, let's do the same thing. The bases are 30 and 12. So the mid segment is 1/2 of 30 plus 12. So it is 1/2 of 42, which means MN is equal to 1/2 times 42 is 21. So MN equals 21 feet. Then we have 2 more theorems, and that's it for theorems for the day. Theorem 8.18 says if a quadrilateral is a kite, then its diagonals are perpendicular. So when you connect the diagonals like this, it's going to form a right angle. And theorem 8.19 says if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So that means those angles would be congruent. And by the way, in a kite, I should write this down, we have 2 pairs of congruent sides. Whoops, let me erase that. But they are consecutive sides, not opposite sides. So it says find the measure of angle T in the kite shown at the right. So we know that we have a pair of congruent angles in the kite. So the 2 angles that are shown are not congruent. That must mean that these 2 angles have to be the same, because we have 1 pair of congruent angles, so it's the pair that we don't know. So now we can say, all right, well, it's a quadrilateral, so 70 plus x plus 88 is equal to 360. So when we add these up, 70 plus 88 is 158. 158 plus 2x is 360. We subtract 158. We would get 2x equals 102. And then divide by 2 to get x equals 51 degrees. So that means angle T is 51 degrees. And then the checkpoint, it's going to be the same thing. We have 1 pair of congruent angles, so it's got to be angle G and angle I. So we'll call those x. So now we have 75 plus x plus 85 plus x equals 360. 75 plus 85 is 160. X plus x is 2x. So we get 160 plus 2x equals 360. We subtract 160 and we get 2x equals 200. Divide by 2 to get x equals 100 degrees. So angle G and angle I are going to be 100 because they have to be congruent. All right, and that's all we have for kites and trapezoids.